Do you have any idea how long I've been waiting for this package to come? I ordered this in March. It's almost June. But it's here. We got a lot to talk about. All things Threadripper Pro. This is the GA WRX80-SU8-IPMI. This is the Threadripper Pro platform from Gigabyte. This is their, I think their flagship board, or at least this is the only board that they have right now. It's a desktop board, but it's for Threadripper Pro. Threadripper Pro, of course, is a big upgrade over regular Threadripper in that you move from 4 to 8 channels of memory and from 64 to 128 PCIe lanes, and you leave behind all things RGB, but you still keep some pretty cool features like a high-end audio solution and, you know, a little bit more aesthetic than plain green printed circuit board. Let's take a close look at the features that this board offers, just at first glance. First, we got our socket. Now, this is turned in a different orientation than desktop sockets. There is a reason for that, and that has to do with routing the memory traces a little bit more easily and a couple of other parameters. Pretty much when you're running a processor like this, you're locked into using a printed circuit board that's more layers than another circuit board. The other reason is that typically these were used in servers, and so the airflow from a server typically is front to back, or possibly back to front, depending on, you know, the whole hot aisle, cold aisle, and who architected your chassis and stuff like that. So this layout actually does make a lot of sense because it's borrowed from the server platform that's been, you know, qualified in server land with server CPUs, because EPIC is just another name for Threadripper Pro, but for the server chassis. But Threadripper Pro does have some tweaks for tuning and speed and stuff like that in more of a workstation class, so it's pretty awesome. 8 DIMM slots, 8 memory channels, 1 DIMM per channel. It's like 2 terabytes of memory support if you can find DIMMs with that capacity. 1 terabyte right now, we'll say official memory support, don't quote me on that, but 1 terabyte of memory support. I actually have 512 gigabytes to test with. Yeah, 64 gigabytes per DIMM. That's a spicy meatball. That's about $3,000 of memory right there. It gives me a little bit of heart palpitations. And no, that wasn't last night's chicken wings. So on this motherboard, you won't find things like RGB, as I mentioned, or even overbuilt VRM. This is designed for TDPs of up to 280 watts and not 1 watt more. We've got the primary VRM delivery system at the front edge of the board, you know, with the system on chip power delivery system at the back, and 2 pair for power delivery for the DIMMs. We also got a 4-pin SoC UART and a dip switch that is completely unmarked. It's not in the manual, it's not in the quick start guide, it's not in any other stuff in the box, which we'll get to because I really like what Gigabyte's doing with their box bundle. But yeah, fun stuff. We have the standard 24-pin power connector and a standard ATX 12-volt connector. This 8-pin connector is not a secondary ATX 12-volt connector. This is actually PCI Express power, which supplies supplemental power to the PCI Express slots. If you're going to run a lot of GPUs, well, potentially they can consume up to 75 watts each through the bus. This is where they get that power, which is good that Gigabyte has done that, although it's a little odd that they didn't opt for the ATX 12-volt standard, which is 4 12-volt wires on this connector. This connector is 3 12-volt wires and 2 grounds, once for sense. So this is not quite as many watts through the 12-volt rail as this one. This is a peak of 400 watts, so again, overbuilt for our 280 watt goals here, but you know, I digress. We've got the 2-digit postcode LED readout, and then we have 3 SlimSAS connectors. SlimSAS 1 and 2 support NVMe or SATA operation, so you can run up to 4 SATA devices off of the first 2 connectors, or a single 4-lane NVMe. The third one is NVMe only, so that's a PCI Express connection. That's 12 PCI Express lanes. Then we have 8 SATA lanes, power, reset, and CMOS clear buttons here at the front with different coloring to help you, which is awesome. Our front panel connection, and then along the bottom edge of the motherboard, we've got 2 5 gigabit USB front panel connections, an onboard USB connector if you want to run, you know, your hypervisor off of a USB stick, you can totally do it. An extra USB 2.0 header. And then we've got 2 connectors here that are the same pin configuration as USB, but they are not USB. They are general purpose I/O pins from the system. Do not plug your USB header into that, you will have a bad time. Then we've got an IPMI header, which is something that you see in servers for the management bus kind of a thing, but it's present on this desktop board. We've got an RS-232 serial port, 2 4-pin fan headers, And then of course the front panel audio connection. And this is, you know, the DAC up Gigabyte Realtek ALC 1220 based audio codec. It is a gamery codec with the 5.1 plus SPDIF thing that you would normally expect on a higher end desktop board, you know, higher end for onboard audio. So it is nice that you have that, because on server boards you typically don't have that. Two M.2 ports which are fully set up and ready to go for PCI Express 4.0 that'll work with SATA or NVMe. Then we've got a connection here at the front edge of the board for system power management bus, a system management bus add-in. Sometimes you have a rack mount chassis or a chassis that reports sensors and some other stuff on the system management bus. That's what that header is for. In terms of 4-pin fan headers, we have a total of 7. 4 of them are concentrated in the front edge of the motherboard. You can tell, again, this is sort of designed for a rack where you would have, you know, 3 banks of fans or 3 hot airflow fans at the front of the board, and having all of the connectors along the front edge works really well. And you might have a connector or 2 for the rear exhaust and maybe 1 just for the CPU. Well, that's pretty much the fan layout that we've got here. Let's take a look at that rear I/O. We've got our 7.1 channel audio solution, our dual 10 gig NIC stack, our dual 1 gig NICs, and then we've got 10 gigabit USB connections, except for the ones that are 20. Then we've got another RS-232 serial port and a VGA. Do note that these RS-232 COM headers are connected to the ASpeed2500, your onboard IPMI solution. Thunderbolt header. Thunderbolt? We interrupt this regularly scheduled motherboard review because somebody said Thunderbolt? Thunderbolt on the WRX platform? Can it be? This is an historic occasion. Gigabyte has delivered, but not only have they delivered, I don't know, I mean, I didn't get confirmation, but every suggestion that I have ever made around Thunderbolt support was incorporated into this motherboard. All right, so in the BIOS, every slot has, you know, X16 or X4, X4, but no X8, X8 option in case you have a more exotic peripheral or a bifurcation thing. Thunderbolt. You know, full disclosure on Thunderbolt support, when you enable Thunderbolt support and reboot, you get a lot more options. Titan Ridge, what sort of compatibility are you looking for, what sort of security level. If you're having problems, you can do no security, which is horrifying, but actually solves a lot of problems. You can boot from, assign resources, and you also have to pick which slot your add-in card is. I recommend the X8 slot for reasons I'm not going to get into here, but especially if you're doing cross-platform stuff like with Linux and Windows and you want Thunderbolt to work, you definitely want the X8 slot for the port that it's going to go in. You've also got the option of native mode or, you know, native plus RTD3 hot or cold. So these knobs and tunables improve compatibility with Thunderbolt, because usually like these commands are just sort of set at a low level in the UEFI and you can't change them, but having these options means that you're going to have better compatibility with Thunderbolt peripherals on this platform. And it's nice that they've exposed these, because they really should have been exposed the whole time, but I mean, it can be a little intimidating for non-power users. So for Thunderbolt to work, you have to enable UEFI with secure boot. If you don't have UEFI with secure boot, the Thunderbolt options are disabled. See, some Thunderbolt devices assume that when they plug in, there's not going to be any security. Like, it's a system bus. You can plug in, you can read directly from memory. At least that's how it used to be designed. That doesn't fly in the security climate of 2021. So Intel's improved on Thunderbolt and they've added more options to it and so on and so forth. I'm using a Titan Ridge add-in card here, and there's a ton of knobs and tunables that are exposed in the BIOS, which can help you get whatever level of Thunderbolt compatibility that you're looking for. Historically, it's been a little hard on the AMD platform to get the newer variants of Thunderbolt and the security and all the stuff around that to work correctly, but not anymore. This actually worked fine in every scenario that I tested, which is really, really awesome. We finally have like full first-class citizen Thunderbolt support on an AMD platform. This could even be a use case for the 16-core Threadripper Pro machine. You got all that PCIe connectivity plus Thunderbolt. Just when you're setting it up, be sure to configure UEFI. You have to use secure boot because of the aforementioned security issues and that kind of thing. You also need to put it in a designated slot and then specify that slot in your BIOS. So there's a lot that you could get wrong, but if you follow the level 1 guide or you look into that kind of stuff, it'll work perfectly. And this is a really, really awesome, unique feature on this board. Alright, back to your regularly scheduled motherboard review. The rear of the board gives us some engineering clues. First off, there are a ton of redrivers back here. PCI Express 4 is a very, very difficult to wrangle thing, and we will learn more about that in the build phase of this video. But at the rear of the board here, my goodness, look at all the redrivers and PCI Express connectivity here. A lot of capacitors for power regulation and cleaning that stuff up, but power, electrical interference, EMI noise, dealing with all of the layers on the PCB. The chipset is located here. It's a lot to juggle. It's an engineering challenge to be able to deal with PCI Express 4.0 across all of your expansion slots. And that's what we have here. Every single one of these expansion slots, except for this one, is fully 16 lanes. And this one is 8 lanes. All 7 of them, PCI Express 4.0. That's incredible. Now, do you see the tiny, tiny kindness that Gigabyte's engineers could have done for us, and they did not? I won't go so far as to claim that this is a flaw in the design of this motherboard, but it is an unfortunate reality. None of the connectors at the bottom edge of the motherboard are a right angle. If you have a very long card, this USB-C front panel connector absolutely for sure will be blocked by whatever you have in this slot. Now, are most of you going to be running a fully populated system with full-length cards? No, absolutely not. If you're going to be running an add-in card that's only half-length, yes, that connector will absolutely clear a half-length card, so no problem. Just something to be aware of. One thing that I like with these boards, if you run them in a really tall case, is that you can hang the really, really big GPUs off of the end. It's a little problematic with this setup if you intend to use any of the bottom connectors on the front panel. I can probably get by without using the 2 4-pin fan headers and just use splitters or an inbuilt control in the fan. It kind of sucks not being able to use the audio connector if I want to run my GPU off of the bottom edge of the motherboard. And of course I lose my 30-pin USB connectivity as well. Fortunately, the 30-pin headers here, if you pick up a right angle 30-pin adapter from the internet, there is enough clearance using a GPU like say a 3090, there is enough clearance to use a right angle connector here if you've got enough room for the bottom of your case to come off at a right angle. I would have much preferred to have these on the front edge of the motherboard with maybe the front panel connectors located here. Just that might have been a little bit more problematic in terms of wiring. I definitely would have moved the USB-C connection somewhere else just to get it out of the way, but you know, hey, how many people are going to run a system that's that fully populated? Admittedly, probably not all that many. You know, if you were doing number crunching or anything that didn't require a GPU, you'd probably have something like this. This is a Quadro P2200. You can see this is a single slot card. This is a perfectly reasonable workstation card, and when you use this, well, nothing is blocked. So as I always say, to really get to know a motherboard, you need to do a build. So let's do a build with this board. So as you do this build, be sure to pay attention to screw placement. Normally there's a screw here underneath the DIMM, and like here underneath the chipset, and like here. This motherboard doesn't have any of those. Also, this screw hole is usually like about right here. So when you're doing this build, you know, I'm getting my layout going here for custom loop cooling and all that kind of stuff. I've really only used 1, 2, 3, 4, 5, 6 screws in this. So make sure that you got your standoffs lining up. You need to take the standoffs out. I've moved them over here so that I won't lose them. So if this machine ever gets a different motherboard, it'll work. But it's very important that you remove the standoffs that are not part of your motherboard's mounting plan from the case. They just unscrew. For this build, I ended up going with the Fractal Meshify 2 XL because, well, I've got room for the GPU thing if I do that, hanging off the end of the board. That's totally an option with this case. And because I could route the water cooling for this in the neatest, most cable managed way ever. I put the radiator in the top. It's an EK radiator, 360 millimeter. I've also got the EK D5 pump with the mini reservoir actually in the bottom. It's got a little bit of a tilt to it so the air will go up. So for draining and filling the radiator, you can just turn the case vertically, which is pretty awesome. You just pop the front off and unscrew the top, and really it couldn't be easier to drain and fill this loop without actually having to have a special drain or fill port, which is, you know, the laziness in me, which is awesome. Also routed the tubing around behind the motherboard. There's enough room for that, so if there's ever a leak here around the pump, it should just, you know, leak onto the desk, and maybe I'll have a clue that something has gone wrong. But I've also got the option for water cooling the GPU in this in the future. Like I say, 280 watts, Water cooling, strictly not necessary. Now, as this is going to be a sort of quasi-test bench computer, I decided to 3D print a fan adapter so that you can run a fan blowing directly over both the RAM and the VRM. And because I didn't want to give up the ultra quiet operation of this case, well, I'm using a 140mm fan. So if you want to 3D print that, I put the model up on the Level 1 Tech's forum. It'll just hold a 140mm fan. It uses the standard motherboard mounts there, so you can use the leftover motherboard mounts in this configuration. Put that 140mm fan there and it's totally fine. I don't think you really need this if you're running with the side on, but if you're running with side off, this works really well. My second choice would be to design and 3D print a shroud that will clamp onto the rear fan and pull air over both the VRM area and the memory. Really cooling the memory is what I'm worried about of this, even more than the VRM. I mean, yeah, the FLIR images are pretty hot, but it's fine. It's basically fine. Thanks, past self, for telling me all about the whole Thunderbolt thing and all of the stuff with that. That is a pretty exciting setup. Now for our build here, I'm using the Fractal Defined XL. Again, I like that for these sort of big systems. It is only a 280 watt cooler. As I said, I'm using a custom loop. It's a little overkill for something like this, but listen to how quiet it is. This is running full tilt, or even just running Cinebench. Like Cinebench R23 at a 10-minute run, peak temperature is reported by the block 45 degrees C, hovering around 43, 44 most of the time, and whisper quiet. The only thing that's maybe a little problematic is when the side is off, there really isn't sufficient airflow over the VRMs and the RAM. If you look at the FLIR thermal imaging camera, we're pushing like 75 degrees C, 80 degrees C in this kind of a setup. 80 degrees C on the VRM side, for the VRMs that are sandwiched between the motherboard and the heatsink. The heatsink is doing its job. And like 70-ish degrees C for the memory. I think what I would do is 3D print a shroud that would use the rear exhaust fan to pull air, you know, over this area and over the VRM. Of course, with the side on, there is enough room because I've got 340mm fans in the front, and the airflow with the side on is pretty good for the motherboard. VRMs are more manageable, like 62-ish under, 45-minute load. And the chimney effect for the top, you can really feel the heat coming out of the top. These are the Noctua 120mm, high static pressure fans, the new ones that are the tight tolerances. And the motherboard will ramp up the RPMs if it needs it. Now this was initially running BIOS FO2, upgraded it to BIOS FO3. If you're used to regular consumer grade parts, there are some key things that you need to know about this motherboard. First, there's no XMP. Even though Threadripper Pro is compatible with regular old gamer memory, there's no facilities in the BIOS to help you set an XMP profile. The reason for that is Threadripper Pro doesn't support any real overclocking. It wants to run at the JEDEC standard 3200. And most memory kits in the non-XMP profile are 2133 or 2666 for their speed at their standard JEDEC profile. And XMP is a secondary profile that has to be set in the BIOS. You can still manually set the settings, but look, if you're going to buy Threadripper Pro, opt for the load reduced DIMMs, opt for the error correcting DIMMs, opt for actual server grade memory actually running at 3200. That is a validated, supported speed. You're not taking your stability into your own hands by doing that. So I wouldn't recommend anything other than registered error correcting memory for this platform personally. Including load reduced DIMMs and the FO3 BIOS will be necessary if you intend to use load reduced error correcting DIMMs. As always, check the qualified vendor list. Buy something that Gigabyte has actually qualified for this motherboard. One other thing I'll mention, I noticed in the build that I don't think I really called out when we were doing the motherboard overview, the two onboard M.2s, those are 80mm. So if you have a 110mm M.2, such as the 800p Optane, or some of the older like P4511 M.2, those are 110. Not gonna work on this motherboard. You're gonna have to break it out or use the slim SAS connections to go to something like the IC dock that we reviewed previously, and then that'll handle it just fine and has supplementary cooling, and you'll be all set with that, not a problem. Another thing to keep in mind if you're not used to the whole out-of-band management server thing is this motherboard uses an ASpeed 2500. It's a computer within a computer. And so, very important things to understand about the ASP2500 that is not specific to this motherboard, but is specific to the platform in general. An ASP2500 is a computer. It is a computer within a computer. And most of the time, the computer will not boot until the ASP2500 boots. So the ASP2500 has to boot up and read from sensors and that kind of thing to make sure that it's okay to boot up. Typically with a desktop board, that same thing is happening with the system on chip. It's just that it happens so quickly that you don't notice that it's taking a little bit to boot the system. So if you use the mechanical rocker switch or something like that, it's going to take a little bit for the ASP2500 to come on. But the good news is the ASP2500 never turns off. Even when you turn off the computer, that ASP2500 is in standby mode. And the ASP2500 has some peripherals that it shares with your host computer. One of those is a VGA adapter. And that's pretty cool for servers because typically you don't want an add-in GPU in a server. You want to use all those PCIe connectivity for network cards or storage or whatever. It is built into this motherboard. You can disable it because sometimes it causes problems. Windows was kind of freaking out because I still had it enabled when I was doing the Thunderbolt stuff. I was getting the little yellow exclamation on it because I never installed the ASP2500 VGA drivers and 3 graphics adapters from 3 different vendors in the system. Kind of freaking Windows out, but once that was disabled, everything was good on the Thunderbolt side. Another thing is the ASP2500 shares its network connection with 2 of the onboard 1 gig NICs. So there's not a dedicated out-of-band Ethernet management port for the ASP2500 IPMI. You can configure that in BIOS and give it its own VLAN if you really want to separate it, but physically it's one wire. It's not really a big deal. The 10 gig X550 Intel, of course, works great. The Linux support on this, of course, works great. If you do go to update your BIOS, another wrinkle is that you got to do that through the ASP2500. So you actually go to the web page, the web management page for the motherboard. That lets you read the sensors, configure the fan profiles, do all of that. And from there, you'll go to firmware, and that's where you actually update the BIOS. There's also another firmware for the ASP2500 itself that can also be updated, but as of the time I'm making this video, there's not any updates that Gigabyte has published for that ASP2500 controller, just the F03 BIOS, because this motherboard shipped with BIOS F02. But this is pretty cool because you can update the BIOS even without a processor installed. You can get sensor readings and stuff. As long as the motherboard's getting standby power, you can remote into it. You can turn it on when it's off using a web GUI. And that's just the nature of these ASP2500, IPMI out-of-band management things. So it's pretty awesome stuff. It's pretty awesome stuff to include in a motherboard review too. So yeah, in closing, Gigabyte has done a really good job putting this motherboard together. All in all, I really like it. The price point really honestly is pretty incredible. I got this one, I ordered it from Newegg. I ordered it from Newegg in like March, as I said, and it took forever for it to get here. So I can't complain enough about that. In fact, I've got other motherboards that I ordered around the same time from Newegg that still haven't shipped yet. They're shipping bundles that have the same part, but they're not shipping the motherboard. That seems like a complaint to the FTC because clearly they have the product and they're shipping bundles with the product, but they're not shipping the product. Something hanky. There's some hanky-panky going on there. But that's a story for another day. If you are building a system like this, make sure that you've got adequate airflow around the whole CPU socket area. It is critical because, again, this platform borrows from the server where it's expected to have vacuum cleaner levels of airflow noise from the amount of air that's rushing through the chassis. But this is perfectly adequate, as I've shown, because this is not a platform that supports overclocking. There's not a lot of coloring outside the lines you can do with this. There's no RGB. There's not really anything on this motherboard that you don't need. And the price reflects that. The price is actually better than some Threadripper non-pro motherboards that are out there, which is really awesome if you just want a no-frills, set it and forget it workstation, which is what this is. We've got the 6700 XT in there along with the Quadro P2200 and my Thunderbolt controller, and I still have plenty of free PCI Express slots. So all in all, I'm pretty happy with this build. I'm really happy with how it turned out. I'm happy with the airflow in the Meshify 2 XL, and I'm also happy with the noise level, which is even lower than I expected. It is astonishingly quiet. It's been on the whole time, and usually you can hear the machines when I'm, blabbering on a little bit, but yeah, no, it's good. So, yeah, this has been a quick look at the Gigabyte WRX80. Thunderbolt support is the headline news for that. I'm Wendell, this is Level 1. I'm signing out, and this has been a Level 1 motherboard review. I'll see you in the Level 1 forums.